Hello, welcome to part 2 of the video mini lesson Introduction to ANOVA, or Analysis of Variance. In part 1, we looked at the difference between independent samples t-test, which can only compare two different samples to one another, to ANOVA, which can compare two or more samples to one another. What's interesting is that the assumptions for both independent samples t-test and ANOVA are the same. And just to review those assumptions are that you have a normal distribution for each group. So you do have to check your descriptive statistics, especially your kurtosis index and skewness index. Also, you have to have homogeneity of variance, and that's referring to the outcome variance for each group. And so, just like with independent samples t-test, ANOVA uses Levene's test of homogeneity, and just like with independent samples t-test, SPSS will calculate Levene's value for you. And remember, your Levene's value has to be above 0.05 probability, because remember, we don't want it to fall into that exclusion area. We don't want our variances to be statistically significantly different, because if they are, then we don't have homogeneity of variance. So this is a situation where you actually want your Levene's value to be above that minimum threshold of 0.05% likelihood of your finding being due to chance. Also, just as with independent samples t-test, your groups have to be independent of one another, and your outcome variable has to be an interval variable. So let's go ahead and look at a sample of ANOVA and talk about it. Now, this sample comes from the International Journal of Educational Technology, and the copyright for this particular article is 1999, and specifically it's volume 1, number 2. So this particular article looked at the analysis of instructional technology use in constructivist behaviors in K through 12 teachers. So one of the things that they did in this particular analysis is they looked at how teachers arranged the rooms, whether they were cluster type arrangement, circle type arrangement of desks, or lecture type arrangement of desks. And they wanted to see whether there was a statistically significant difference in teachers based on how they grouped their desks in a room, and the degree to which the teachers are constructivist. And for those of you who are not familiar with constructivism, and I'm quoting directly from page 2 of this article, constructivism is based on the assumption that people create knowledge as a result of interaction between existing knowledge or beliefs and new knowledge. The role of the teacher then would be to encourage interaction between students' existing knowledge and new experiences. The emphasis is different from the transmission model in which teachers attempt to convey knowledge directly to students. There are several instructional approaches that can be derived from this philosophy. So I'm asking you, based on that definition of constructivism, do you think that there would be a statistically significant difference in level of constructivism based on how a teacher arranges the desks in her or his room? So take a minute to think about that. What is your prediction? All right, now I'm going to actually show you the Anova table for this particular analysis. And what you see here are all your sources of variation between groups, within groups, and total. You see the sum of squares for each. You also see the degrees of freedom. And remember, the degrees of freedom for between groups is k minus 1, where k is the number of groups. So the degree of freedom is 2 because we have 3 groups total. We have cluster groups, or a group of teachers who cluster their desks, a group of teachers who use the circle type arrangement, and a group of teachers who use the lecture type arrangement. So those are our 3 groups. So k minus 1 is 2. And then our total number of participants in this study is 418, because our degree of freedom for our variance total is n minus 1. So 418 teachers total. And then within groups degrees of freedom is our N, a total number of folks from all the groups together, minus the number of groups we have. So that would be 418 minus 3 groups, so that's 415. So that's where those come from. Here are our mean squares, and then here's our F value, our calculated F value. And remember, F is, conceptually speaking, the variance between groups divided by the variance within groups. And remember, if you want to in order to reject the null hypothesis, you need to have a small within group variance and a fairly sizable between group variance. So you need to compare your calculated F value to the lookup table exclusion value for F. And in order to use that table, you need to sort of use your degrees of freedom between, which is in columns, and your degrees of freedom within, which is in rows, and come and find the appropriate exclusion value depending on on your sample sizes and your degrees of freedom from those. And then what's nice about SPSS is it will calculate the exact probability of this F value being a finding by chance. So in this particular analysis, your exact probability is 0. So when you would report that as a probability of chance finding being less than 1/1000th. So as you can see here, there is a statistically significant difference in teachers' degree of constructivism based on how they arrange their desks. So this finding, this data would support the alternate hypothesis, or would suggest that we need to reject the null hypothesis, but we still don't know specifically if which of these groups are statistically significantly different from each other. So what we would do is perform a post-hoc analysis, and again, Tukey's HSD for honestly significantly different is the most common. And so that is exactly the one that these particular authors use. And I know this typing is going to be too small for you. Now, they didn't put their Tukey's findings in table form. They put them in the narrative in paragraph form. But what they did, and I'm just going to tell you what this says because it's probably too small for you to see, but essentially they found that there was a significant difference between teachers in each of these two groups and the teachers who arranged their desks in lecture style as far as the degree to which the teachers were constructivist in their teaching. Also, they found a statistically significant difference between teachers who cluster their desks and teachers who use a circle type arrangement. So actually, there was a statistically significant difference both between and amongst all 3 classroom arrangements. But I did want to show you what a Tukey's HSD table can look like. So this is from a completely different study, but this particular study is looking at different approaches to parenting, philosophies of parenting, and it looks at how those different parenting styles sort of vary on different components of media use and supervision. So this is how Tukey's HSD is usually reported in table form. So you'll see the different values, and then you'll have these superscripts, and you have to go down to see what the superscripts represent. But usually Tukey's HSD is any superscripts will refer to a probability of chance finding being less than 0.05. And then you have to use these little superscripts to see which different styles of parenting are statistically significantly different from each other on each of these different kind of media supervision components. So for this first one, for example, this finding is statistically significantly different for the laissez-faire parents as compared to the protective parents as compared to the consensual parents. So these 3 groups are statistically significantly different from each other on this co-viewing of media with their children. And the second one, which is discussed with children about TV commercials, there was statistically significant difference, again, between the laissez-faire parents and the consensual parents, but this time also there was a statistically significant difference between laissez-faire parents and pluralistic parents, and then also pluralistic parents and excuse me, but then here for the second one, this is just an example. Pluralistic parents were statistically significantly different from not only laissez-faire parents, but also protective parents. So you have to kind of go through the chart and see which arrangements are statistically significant to one another. And I'm not going to go through the rest of this chart, but I did want to give you a sense of how to read a Tukey's HSD paired comparisons chart. So this concludes part 2 of the Introduction to Anova. And if you have any questions, please let me know. Thanks.